So folks, Calculus 3 is not a prerequisite for this course. However, we're going to have to work a little bit with partial derivatives. We're going to do this on a superficial level, so please don't feel like after you see this video you're supposed to fully understand what a partial derivative is. All I'm hoping for is that after the end of these videos you'll be able to compute partial derivatives, even though we may not have a full grasp of what we're doing when we do so. So again, the purpose of this handout is to provide a superficial introduction to partial derivatives, and we'll discuss that here in just a moment. Before we get to partial derivatives, I need to introduce what are called multivariable functions for you. If you know multivariable functions, feel free to just fill out the rest of this portion of the pre-work and join me in the next video. So I'm not going to give a full introduction to partial derivatives. If you are interested in those, please click this link here where I do a similar pre-work to this, but it is a much more thorough introduction to partial derivatives. And you can see that I've got a few different reasons why we want to learn partial derivatives. First of all, to distinguish between the ordinary and partial differential equations. The next thing is when we give what are called some of our existence uniqueness theorems, the conditions of those theorems are usually stated in terms of partial derivatives. And lastly, we're going to learn how to solve a certain type of differential equation called an exact differential equation. And that will involve some knowledge of partial derivatives as well. So, but before we can even do that, we have to talk about multivariable functions. So a function of the form, let's say y is equal to f of x1, comma, x2, comma, dot, 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 comma, xn. So you can see I've got a function here, f, and I'm inputting n different independent variables into it to get out some value y. So a function of this form is called a multivariable function of n independent variables. And really I could be more precise by calling this a real-valued multivariable function. Feel free to read the footnote for a more careful explanation. So for many of you, this might be your first time seeing a multivariable function. So the way I want you to think about it is, in this case, for this example here, we're going to take two different independent variables and input them into the function, and that will compute the value of a third variable. So for example, all I'm asking you to do in this problem is to evaluate the function f at the ordered pair 2, 18. So again, rather than inputting a single number, we input an ordered pair. So f of 2, 18 would be equal to, and so everywhere I see an x in the description of the function, I'm going to replace it with the first input variable. And everywhere I see a y in the second in the function, I'm going to input the second independent variable, 18, the second value for that independent variable. So here we go. We've got 2 cubed minus 18 plus the square root of, let's see, yx, so 18 times 2. And then we just simply simplify this. Negative 10 plus 6 comes out to be negative 4. So the next thing I want to do, so that's just to show you a little bit about the mechanics of multivariable functions. We took two inputs and we got out an output, and we're using that same function notation that hopefully you're familiar with. So now I want to represent this fact that we just found, that we computed f of 2, 18, we got out negative 4. I want you to represent that fact as an ordered triple. So how would we represent it then? It would be the ordered triplet 2, 18, negative 4, where this is conveying the same information that an ordered pair does with real-valued functions of one variable. The difference here is that it's understood from context that the first two entries in this ordered triplet have to do with the domain, and the third is the corresponding range value. And that's given to us from context. So here I'd like you to represent this ordered triplet as a functional statement. So if we wanted to represent that as a functional statement, what we're saying is if we were to take the ordered pairs 4, 9 and input that point into this multivariable function, it will output the range value 61. So folks, that was supposed to be just a quick intro to multivariable functions, and now we'll learn how to take their derivatives through one type of derivative operation called the partial derivative. I'll join you in the next video.